So this project will focus on converting the VHDL code of the 8-bit divider into a PSice model using the Simplicity software. We are going to extract the file into our program folder, but if you are doing this on your own, you can save it anywhere. Now we're going to open up the Simplicity software Simplex Pro program. We're going to create a new project and a new project file. We're going to use the VHDL code from Xilinx to create the .vhm file, which will be imported into Cadence Capture. Make sure that you disabled I/O insertion and write map VHDL netlist. Once compiled, it creates the sub8.vhm file. This file will also be saved in your project folder. And you can call it div8.vhm. Next, we're going to run the VHDL to PSice program in administrator mode to convert the .vhm file that we just saved. So now the main entity is the top level name of your design, which also happens to be div8. Once the conversion is successful, you can close out of that program. The next step is to open up Cadence Capture CIS and create a new file. Create a new project. Create a new library. Sorry. This library will be saved along with your other files in your project folder. And you can name your divider whatever you want. As you can see, all the files were generated. We're going to open up Cadence's model editor. open up the copy of the library that you just created. As you can see, you can observe the pins that are in your model. So what we're going to do right now is just clean up the file so that you're able to determine where your pins will be connected on your model. Once you finish assigning your pins, we're going to save the parts into the model library. As you can see, this is where your library model is saved. We open up OrCAD Capture and open our divider project. As you can see, this is a pre-made copy of the device that was converted from your VHDL code to the PSice model. We added our divider into our libraries. That way we can select it from the part menu. To prove that it works, make sure that you initialize all your flip-flops to 0 to avoid any errors. We have a pointer that is added into the configuration file of your simulation settings, so the program knows where to look for your connections. So for A, we're going to use the value FF, and for B, 0, 1. Obviously, the result of the simulation, FF divided by 1, should result in FF being your Q. So as you can see, FF is your quotient, and 0 is your remainder. This can be done for different values. So for example, F1 will be changed to, F1 will be A, and F will be B. For your quotient, you get 1, 0, or 16, and for your remainder, you will have 1.